All right, so now we want to take the trig functions and we want to be able to do them for any angle. So right now when you've done SOHCAHTOA in geometry, you had to be an acute angle in your triangle because the right angle or the two other angles had to be acute. So we could only deal with trig functions for acute angles, but we need to be able to do trig functions for any angle. So what we want to do is see how we can extend what we know. This is not a unit circle, it's just a plain old circle. So this R, this radius right here, we don't know exactly what it is, but it's the hypotenuse of the right triangle that I've just drawn in there. The x value is how far you went over. So the x value is the adjacent side of that angle theta. And then we have the y value, which is how much you went up to go to the point. So the y value is the opposite side from the angle, and then we can do our SOHCAHTOA things with our opposite, adjacent, and hypotenuse. So instead of the hypotenuse, we're going to start calling it r for radius. Instead of the adjacent, we'll call it x for the x value, and instead of the opposite, we'll call it y for the y value. So this says use the Pythagorean theorem to find the length of the hypotenuse. So if I started out with my r squared, my r squared would be equal to x squared plus y squared, right? And then we'd have to get r by itself, so we'd take the square root of both sides. Normally when I take the square root of both sides, I need to put a plus or minus there, but I'm not going to put a plus or minus there because mine is an actual radius of that circle, and the radius is always positive. So my r value will always be positive, okay? Because it's the actual length of the radius of that triangle we've just shown in the circle. All right, so that worked because it was an acute angle, but in this example over here, I have my theta is an obtuse angle. If I look at my reference angle theta in this little spot right here, I can still draw a triangle. So my x value is going to be how much I went to the left, which is now going to be negative, but it's still the adjacent side of the triangle. My y value is now going to be how much I went up, which in this case is still going to be positive, and it's going to be the opposite of my theta. And my radius is going to be the hypotenuse of the triangle, and my radius is always going to be positive because it's a radius. Okay, so x and y we're going to allow to become negative, but whether they go down or to the left, but my radius will always stay positive. So using my ratios over here, the sine was the opposite over the adjacent. So the opposite would be y, and the adjacent would be the radius. So the sine is now going to be y over r instead of opposite over adjacent. It's the exact same thing as opposite over adjacent, unless y happens to be negative, okay? The cosine is going to be the adjacent over the hypotenuse, so that's going to be x over r. And in this case, since my x is going to be negative if it's on the left, my cosine of this angle should be negative, and that's what will happen. The cosine of an obtuse angle is negative. The tangent is the opposite over the adjacent, so the tangent is y over x. Oops, that should be green. Okay, so the tangent is y over x. Those were the SOHCAHTOA, the three primary trig functions. Then we had three more trig functions that some of you may have seen, but some of you haven't. This one, CSC, that's the cosecant. And the cosecant flips the sine. Okay, so if the sine was y over r, then the cosecant is r over y. Okay. The next one is the secant. I'm just putting it out so you can see how to spell it. So the secant is 1 over the cosine. The secant flips the cosine. So if the cosine was x over r, then for secant, the x is on the bottom and the r is on the top. I just flip them. Okay. And then the last one down here is the cotangent. the cotangent flips the tangent. So if the tangent was y over x, then the cotangent is x over y. So those are the 6 trig functions that we need to know, all of the regular ones. And then these 3 right here, they're all flipped. We call them the reciprocal functions. Okay. The reciprocal trig functions are the cosecant, secant, and cotangent because they are the flip of the sine and the cosine and the tangent. So we don't want to confuse reciprocal with inverse. Back when you did triangles and you had like, here's the flagpole, here's the shadow, what's the angle of elevation, and you hit the inverse tangent button on your calculator where you put the sides here and it gave you the angle, that's an inverse function. Whereas these are called reciprocal functions. We have 2 ways of doing opposites, sort of. We can flip or we can switch the input or the output, so don't get them confused. So in this one, we're supposed to find the exact values of the 6 trig functions for the angle theta. So we're supposed to find the sine of theta, the cosine of theta, the tangent of theta. And then if I flip each of those, when I flip the sine, that's the cosecant. When I flip the cosine, that's the secant. And I flip the tangent, that's the cotangent. All right, so looking at my triangle, I have a point right here that's on the terminal side. I have to draw my reference triangle. So my reference angle would be the acute angle between the terminal side and the x-axis. So that means my adjacent side is going to be how much I went over to the left here, which would be my x value of my point, which is -3. My opposite value would be how much I went up. Is my board freezing up again? No. So this one, how much I go up, is the y value of my point. So that is a +4. And then I need to do Pythagorean theorem or just look at it and know what it is to figure out my hypotenuse. It's a 3, 4, 5 triangle, so that's 5. So I can either do the Pythagorean theorem or just know what it is. So the sine. The sine is the opposite over the hypotenuse. So the sine is 4 over 5. Again, you can think of it like opposite over hypotenuse or as y over r. It's the same thing. Okay. The cosine is the adjacent over the hypotenuse. So in this case, because I'm using a reference triangle there, I have to call the cosine -3 over the hypotenuse or the radius of 5. So my cosine just goes -3/5. Then my tangent is my opposite over my adjacent, or my y over my x, which is -4/3, 4 over -3, however you want to call it. For the cosecant, I flip the sign, so that's now 5/4. For the secant, I flip the cosine, so that's now -5/3. For the tangent, for the cotangent, I flip the tangent, so that's -3/4. Okay. It doesn't matter if I put the negative on the top, out in front, or on the bottom. So long as there's only one negative, those are all the same thing. Okay.